Hello, so today we're looking at week 4, area of a sector and arc length. What we're doing with this is we're connecting the idea of formulas to find area and circumference. We've been studying formulas the last 3 weeks, surely, with the idea of a circle. And so we would normally do an entire circle unit. We're only going to get through 3 lessons in that circle unit, and this is one of them. We thought it was a good transition from the formulas into the circles. So the first thing we need to talk about is a little bit of vocabulary. And so when we look at this, what we have here, this shaded gray region, is the part that we want to find the area of. It is called a sector. You can think of a sector as like a slice of pizza or a slice of pie out of that circle. Now, it could be a very small piece if you don't eat too much, or it could be a very big piece if you eat a whole lot, right? So this white section here would also be considered a sector. So the main thing is it's just a part or a piece of the circle. Now, when we find the area of this part or the piece, we're going to use this formula up here. Rather than just plug it in and do it, I want to talk a little bit about where each piece of this formula comes from. So the first thing that we're going to look at is this little formula right here, and everybody should recognize this. This is area of a circle. And then what we're ultimately doing, so that's what's right here, we're going to take that and we're going to multiply it by x over 360. This is the part we want the area of. Let's say area 4. All right, so now all we have to do to solve this, and you can use this original formula or you can use this version that I've set up here. You are going to want to use the pi button in your calculator as you're working on this. Okay, so all we're going to do to figure this out is to get the area of this sector, we're going to do pi times, now we've got to identify our radius. Now, sometimes they'll label them on the picture for you, but that isn't always the case. So if we look up here, they say JK is equal to 3 millimeters. So this line right here is 3 millimeters. And if you look carefully, I'm pretty confident you all will see that that is in fact a radius. So we're going to do pi times 3 squared, so pi times radius squared. And just in case you forgot, let me give you a little reminder. From center to the edge, that's the radius. From one side of the circle all the way across, this is diameter. And these are generally the ways they're labeled. If it's going to be diameter, they're going to put it centered over that center point. A radius is equal to half a diameter. The diameter is equal to 2 radius, just so we know. All right, so now we're going to take this value and we're going to multiply it by the fraction that represents the circle. Every circle has 360 degrees inside of it. So to solve this, we're going to take the degree measure of the arc, the 84. And so for this circle, we have 84 degrees out of the 360 total. Okay, so that fraction represents the piece of the circle that we want to find. Now, to do this in your calculator, the easiest way, in my opinion, to do it is to do pi times 3 squared times 84, hit enter or equals, and then do divide by 360. So if we do all that, and I've got my calculator next to me. With these PowerPoints, I don't have as easy of a time as trying to show you the calculator on the screen. So you're going to press your pi key in your calculator. We're going to do times 3 squared, and then times 84. Press enter or equal, and then divide by 360. Now you'll notice in the directions for the lessons, or the lesson, excuse me, it's going to have round to the nearest hundredth. So I'm going to write out what's on my calculator display. Okay, and we're rounding to the 100th, which would be this one right here. So this would be 6.60 if we're going to be precise, and actually, and I don't know why I put a straight equal sign, this is approximated. So it would be 6.60, or in the form, I should also accept 6.6, and I will be double checking that before I post it. Either one of these is valid. A lot of people are really kind of crazy about the direction, and if it says round to the nearest 100th, you have to have a digit to represent the 100th place. These two values are equivalent, and I'm not that picky because that 0 isn't really necessary. So either way you round it would be acceptable to me, but be aware that other people are going to be a little different about that. All right, so that's our first problem. We're going to look at a couple more. Now, this one is about as intense as it'll get. What's going to happen here is we are still looking for the shaded area. And if it doesn't say that in the direction on the form, I'll make sure I correct that in a minute. But you're always looking for the shaded area. And so you've got to remember the whole idea that the whole circle is 360. And you're also going to have to use the other angle relationships that we've just studied all year. I'm very proud of you, boy. All right, so if this one is 143, the angle straight across from it, the vertical angle is also 143. There's a couple ways we could look at finding the gray degree measure. One of them is you could realize that right here, this arc right here, or this line has to measure 180 degrees total. So you could do 180 minus the 143. And this is my personal preference because it's a little faster. The other way you would have to do it is you would do 360 minus 143 minus 143. Whatever's left, you would divide it by 2, and that's what both of these are. If I subtract this, I'm going to find this one right here. And then again, vertical angle rule says that these two have to be the same. So I'm going to get 7 when I subtract that, and 3. So this has to be 37. And this has to be 37. So now that we know these are both 37, what that fraction in our formula represents is the total degree measure of the sectors we want to find the area of. So even if it's more than one sector, we're just going to add those together. So you could either add them or multiply them by 2, and we're going to get 74 degrees total for the two shaded regions. So now we're going to do pi r squared, so area of the circle, times the piece of the circle we want to find the area for is 74 degrees out of a total of 360. So then now they tell us that E to B, which is nice because is that a radius or a diameter? That is a radius. So this is a radius of 10.4. So we're going to do pi times 10.4 squared. And again, my personal preference is to multiply the 74 and then hit equals to figure out what that is. So let's do that real fast. So we're going to do our pi key in our calculator times 10.4 squared times 74. And so I'm getting this really big number. Oh, I keep trying to write on the wrong thing. 25144.804 da 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 da. You get the idea? And then now once I have that in my display in my calculator, I'm going to divide by 360. The other way you can do it is you could put this in parentheses if you want to try to key it all in the calculator in one line. If you do not put this in parentheses, it will cause some issues, I believe. I'm a little nervous about that. I don't trust calculators a lot. It may work. You'll have to let me know. We may have to try it. All right, so divide by 360, and we get 69. I'm going to just write a few of the digits. 69.846668. Let's stop there because we are rounding to the 100th all the way through this form. So is the 6 going to tell the 4 to stay the same or go up? Go up should be. So our approximate answer will be 69.85. Robert, please turn that down, baby. So this would be all you would do to this one. So I went kind of quick. You can rewind and rewatch, but let me revisit just a little bit. And I really think that you might be able to do that without the parenthesis. Let me just test it because it's all multiply and divide. So it should happen at the same time. It shouldn't be an issue. So let's double check just so you'll know. I should have did it before I started recording just to check. I really don't trust calculators much, so I have issues. All right, so times 74 divided by 360. Let's see if I get the same answer. You know what? So it works. So I was totally wrong about the parenthesis. You don't really need that. You can just type in that whole string of stuff. You don't even have to hit the enter in between. So I apologize for the extra step, but again, calculators really make me nervous. So the main idea is that you want to make sure that you add any of the degrees for the shaded region. Use the things you know about degree measures of lines, circles, and those vertical angle relationships to help you finish it. All right, let's go to the next problem. And I think we might be on to the arc section already. Yes, we are. All right, now arc length is a linear measure. We're not talking about how much space is occupied by the sector. We're talking about how long is this line that's captured by the sector. So see this bolded line right here? And you will have some problems in the lesson or the assignment that ask you to find the length of the bolded arc. And so the bolded arc, you want to watch really carefully because one side should be very dark and it can be the bigger side of the line. Or the circle. So we're talking about a piece of the circle circumference. That's what an arc is. It's a little piece of the curve on the circle. And so we're doing a little more vocabulary here. So the arc is the length. The arc length is a piece of the circumference. The arc is a piece of the actual curve of the circle. All right, so what we're going to do is we're going to find the length of this by doing a couple of things. Now, this formula is a little bit harder, and the reason is we have two versions for circumference. So you can use a circumference formula if you know the radius, or you can use a circumference formula if you know the diameter. And so really we put the C up here in the standard formula because we want to still give you the choice. So when I look here, I can see in this illustration that I have the radius of the circle. So what I'm going to be using for circumference is 2 times pi times that radius of 11. So this is just to find the entire circumference of the circle. Just like with area of a sector, what we're going to do is we're going to multiply that now by the fraction that represents the piece of the circle that we want to have. We want to know only the circumference or length of this piece right here of the circle. And this piece measures 75 degrees out of the total 360 degrees of the entire circle. So again, you take the entire circumference and you multiply it by the fraction of the circle you're interested in. Now, thanks to my previous error, and I'm so not re-recording this video because I'm tired, what you're going to do is you're going to multiply all of these numbers together. And then, whoops, sorry. And then the last thing you're going to do, I'll get it together in a minute, is you're going to divide by 360 in your calculator, and you should be able to get the calculator's approximate answer. So 2 times pi times 11 times 75, and then divide by 360. So this is mostly just a big exercise in button pressing. And we end up with 14.398966. We'll stop there. So we're rounding to the nearest hundredth, which is this one. When I look at the 8 is going to tell that 9 to increase. So it's going to be approximately 14.40. Again, I'm okay with this, but some people are not. You can also do 14.4 because the 0 isn't necessary. If they're really critical, you always want to put that 0, even though it's not necessary, because if they're saying they want it rounded to the hundredth, a lot of people want to see that place value represented. All right, so that's all there was to that one. I think we've got one more that's a little more complex, and then our video instruction will be done. Don't forget that all your teachers are offering office hours if you need extra assistance. All right, so what they want us to find is they want us to find the length of MKL. So since they didn't bold it for me, I'm going to go ahead and trace it. Now, this is really important. You have to go from the first letter to the second letter and then to the third letter. Because if I go MLK, that's a different arc. So I have to go first letter to second letter to third letter. Now, one thing we want to notice about this is that MK is 10 units long, and this MK value here, this is a diameter. So I need to notice that. I also need to realize that if it's a diameter, it's a line, and so all of this right here is going to measure 180 degrees. Now, the other thing I want to see is this little block right here means this is 90. So on this 180 degrees, I need to add this little piece between K and L, but I don't have a number for it right now. However, I do know this one is 52. So if this one is 52 and the whole thing is 90, all I'm going to do is 90 minus 52, and I get 38. So this piece right here has to be 38. So the last thing I would do is 180 plus the 38, and you will have several difficult problems like this. There are also going to be some word problems, and this is because we're really trying to challenge you a little bit. Now, be aware again, for most of us, I believe a 70% should be good enough to get you through. So if you're really struggling with those, you don't have to sweat it too much. It would be nice if you contacted one of us and asked for some help, because it would be wonderful to see you really trying to understand these more difficult problems. All right, now to recap, we took the 180, we added the 38 to it, so now we have the degree measure of the entire arc that we want the length of. So to find the length of this arc, I'm going to choose to use the circumference formula that's pi times diameter. Again, it's always the degree of the arc over 360. So this is the formula I'm going to choose to use to find the length of the arc. So the length is going to equal pi times our diameter is 10 times the length, or excuse me, the degree measure of our arc this time is 218. And that's out of a total degree measure of 360. So when I go to do this in my calculator, it's going to be pi times 10 times 218. And then we're going to do divided by 360. All right, so let's do that real fast on my happy little calculator here. I feel like Bob Ross today. I don't know what's wrong with me. Okay, and then we're going to divide by 360. And I'm ending up with 19.024. Oh, and then a whole mess of eights. So we're stopping there. I've got a little bit more in my display. All right, we're rounding to the nearest hundredth again. And when I look at that 4 is going to tell it to stay the same. So the answer to this should be approximately 19.02. The 4 is going to tell it not to change. I hope this lesson helped. I hope you find it easy to complete this when you start the assignment. Again, don't forget about our office hours or to contact us by text or email if you're having difficulty. Good luck.